Because these are things that maybe some of you already know. When I say the word quadratic function, yeah. Yes. Cool. I mean, there should be some other people because I printed out precisely enough for the number of people I have in the class, and I have extras. So when I say quadratic function, what do I mean? What is a quadratic function? I'll tell you though, it's like an example of a quadratic function. Cool.
Square.
Yeah, like something squared. And that's actually like where the word quadratic comes from. It's either straight from the Latin for square or it's from the German, I'm not sure which, for square. So quadratic function is a function that has to do with a square. And that's not like a hard and fast definition. We'll give a definition in a little bit. You see quadratic functions come up sometimes. What are some things that behave quadratically, behave like squares? There's one example that we've definitely seen a few times in class. Things in free fall. All right. As long as lighting doesn't strike in the classroom, I'm fine. So think like things in free fall. Or how about this? Like if you have some shape that's changing over time, probably you're going to multiply width by height at some point to compute an area. So if this has a linear behavior and that has a linear behavior, when you multiply them, you'll get something quadratic. So, I don't know, areas of things. Any other things spring to mind? Or you'd want to multiply two things together to get a result? Okay, I'm happy. So what are we going to do with quadratic equations? We're going to talk about how to solve them. And maybe I'll even say this. If I write down the word quadratic formula, it's going to be stated on the next page. People just already know what that's going to mean. Cool. Yeah. And the last thing that we will do is a technique which is really powerful about quadratics and is really the thing that just makes them easy to study. There's a technique called completing the square, which lets you put quadratic functions into a very nice form. You can then use that form to get anything you want out of them. Seem like a reasonable place to start? Nice. All right, so the key example that, at least in the notes, I had second thoughts about whether I wanted to change this example, but it was already printed. So suppose you go up to the top of Hebron. I guess not today because there's storming. Which I saw is about 45 meters up. Didn't measure it. Seems about right. And drop a bowling ball. The height of this ball as a function of time is now given by the following formula, according to physics. Some term that comes from acceleration due to gravity, plus the initial position. And since I'm not including the units in the formula, I have to specify them somewhere. Time is measured in seconds. Height in meters. If I wanted to use feet instead, I'd need to tweak all those entries. All right. So there's some formula for the height of this ball as a function of time. Let's suppose you want to know when this ball will land. How long is it going to take to hit the ground? What equation do you need to solve if I ask you, when does the ball land? What does it mean for the ball to land?
Make contact with the ground.
Say louder.
Make contact with the ground.
Makes contact with the ground. I like that. What's it mean in terms of the formula?
H is 0.
Height is 0. Right? That's what it means for it to be at the ground. So, what equation do you need to solve if you want to know when the ball hits the ground? You just need to set this equal to 0. That seems like an equation you can just solve? Let's solve it. I don't know. If you feel like just sitting quietly and doing it, go for it. If you'd like to talk through, then, I don't know. What seems like a good false move if you wanted to solve that for t? Yeah, say it louder. I like that. Subtract 45 to the other side. Giving you minus 5t squared equals minus 45. What next?
Divide by 5. Well, negative 5.
Let's divide by negative 5. Otherwise, I'd have to split that up into like 2 steps. Giving me t squared equals 9.
Square root.
Take a square root. And so that will give me t equals, I'm going to put the plus or minus root 9, also known as plus or minus 3. Square root of 9 is 3.
It doesn't matter here, right? Because it can't be negative to the ground.
Yeah, so let's think about what the negative time would even mean. The negative time would suggest that like before you drop the ball, it's already on the ground. So instead of dropping the ball, you just had your hand out, the ball flew up from the ground, tapped it, and then fell back down. That's not reasonable. That's not what happened. Time equals negative 3. You shouldn't think of as being in the domain of this function. T equals 3 is the only sensible result. So at t equals 3 seconds. Right? Even if you suppress your units through all of the walk, if you want your answer to mean anything, you should include the units. 3 is not a time. 3 seconds time. That feel pretty good? All right, so cool. A quadratic function is any function like this. A quadratic function is any function, just like how linear we said can be put into the form, any function that can be put into the form ax squared plus bx plus c with a, b, and c, Gesundheit, constant. So, that function, is it a quadratic function? Yeah, I guess the b is 0, the independent variable is t instead of x, but that's fine. A quadratic equation, so a function isn't an equation, a function is just like a formula with an independent variable. A quadratic equation is anything that can be put into the form 0 equals quadratic function. Nice. Feeling pretty good? So here's something that's like annoying about the strategy that we just used. The strategy that we used above, like it walked because there was only one x in the formula. Right? We could just get x on its own directly. If we want to apply that same philosophy on this problem, we'll kind of get ourselves stuck. Right? We like move 2x plus 4 to the other side, but then there's an x on both sides, so that's not solved. Even if you take a square root, there's still an x on both sides, that's not solved. So you need some other tools to solve quadratic equations. And the most popular tool, the easiest one to use, well, this is wrong. The most generally applicable tool for solving a quadratic equation is the quadratic formula. The quadratic formula says that there is a formula for the solutions to a quadratic equation. Now let's write it down on the next page. So the quadratic formula says the equation ax squared plus bx plus c has solutions given as follows. And the solutions are, I mean, I don't know. Some people raise their hand when asked if you just already knew the quadratic formula, so let's hear it. And people just remember it. I guess I asked if you knew that there was one. Yeah, let's hear it.
X equal negative 3 plus or minus the square root b squared minus 4ac all over 2a.
Nice. And that formula is definitely a formula worth having just internalized, because it's often enough that you need to solve a quadratic function. And it's annoying if you have to like look up this formula each time. One of the extra credits is going to have you derive the formula which will mean you don't have to remember, you can just remember how you build it from scratch. Cool. So now that we have that formula, let's use it to do something. Yeah, I think this one's fine. You know what? I'm going to tweak this a little bit. I'm going to replace that 1 by a 6 just to make sure that something particular happens. Does that look like an equation that you can solve using this tool? I think so. Maybe one thing to worry about first. The quadratic formula only works if you have a 0 on the right-hand side of the equal sign. Do you have a 0 on the other side of the equal sign right now? Can you, though? Yeah, what should you do if you want a 0 on that side of the equal sign? Cool, let's subtract 6 from both sides. So subtract that 6, which is like maybe the opposite of what's intuitive, right? Usually you want to get x on its own. This time we're getting everything onto the same side. You'll get x squared plus 2x, oh gosh, minus 2 equals 0. Now we're in a form to use the quadratic formula. So let's use the quadratic formula. What has the role of a?
X squared.
Yeah, it's close enough to the answer I'm looking for. I'm looking for 1. Right, a is the coefficient in front of. So because there's like a 1x squared, you have a equals 1. What's b?
2,
2. What's c?
4, no, -2.
Negative 2. Very nice. So usually when you're using the quadratic formula, you won't take the step where you explicitly write out the coefficients. But, you know, it's nice just to make sure we're on the same page to do that. That enough to use the quadratic formula? Gesundheit. Let's do it. We will wind up with x equals negative b, so that's negative 2, plus or minus the square root of b squared, that's 2 squared, minus 4 times a is 1, times c is negative 2. All over 2a, so that's 2 times 1. And in one sense, like, there's the answer. There are 2 of them. I guess one of them has a plus, the other one has a minus. In fact, WebWalk doesn't care if you simplify. You could like just type in those 2 answers separated by a comma and WebWalk and it'd be happy. Usually. Some problems will say, nah, you're not allowed to use the square root function.
I had some problems with simplifying stuff and telling me it was wrong.
Yeah, so here's an upshot. WebWalk, you don't necessarily need to simplify. It's got a built-in calculator. Anyway, we have that written down. If we wanted to simplify, could we? In fact, if you turn this in as your final answer on like a test, I'll say, oh, this isn't the final answer, you haven't simplified. There's not a whole lot of simplification to do. Negative 2, plus or minus. I guess we just have to evaluate out what's inside the square root. And I think I stalled long enough. How many people have just already walked out what's under that square root? I think it's 12. Well, you could have just told me that. Do people want me to walk out those details? All right, 12. All over 2. And now that I've done that, I think to myself, well, that's not fully simplified now. There's one more thing I would want to do. Whenever you see a square root, you should ask yourself, are there any perfect square factors under that square root? Because you can pull those out. And if you do that, maybe there's more canceling you can do. Does 12 have any perfect square factors?
4 and 4. Wait, no.
4 and 3. 4 times 3 is 12. But 12 has 4 as a factor. So let's see, I'm going to off to the side do this. So 12 is the same thing as 2 squared times 3. 2 squared being 4. I can pull that 2 squared out of the square root. That's the same thing as 2 root 3. So what do I see? I see negative 2 plus or minus 2 square root 3 all over 2. And that looks a little bit nicer than before. 3 is a smaller number than 12. Now that we've done that, any more simplifying to do? There is.
Divide both by
everything in the numerator has 2 as a factor. The denominator is 2. So everything in the numerator you should think of as being even. Denominator is even. Same thing as -1 plus or minus root 3. You can divide everything in the numerator by 2. Does that feel pretty okay? Nice. So, Gesundheit. When using the quadratic formula, there's an upshot. The upshot is that there's no algebra to do. You just have a formula for the answer, you can apply it. The downside is it's not going to give you the most simple answer. You probably have to do some simplifying. That seem fair enough? And in order to see the trade-offs in this, I want you to do the quadratic formula on your own now. There's an equation, x squared plus 6x minus 16 equals, well, that equation. Does that look solvable? Yeah, I think so. Anyone want me to talk through it instead of just cutting you loose? All right. Apply the quadratic formula, find yourself a solution. As you proceed, maybe if you get stuck at a point, ask questions of your neighbors, maybe even raise your hand, I'll come around. You can ask me anything you want. Is the screen big enough to be readable from the back there? Okay, cool. Looked like you were squinting just a bit. I'll zoom in anyway.
I have glasses, I just don't wear them.
Okay. That's an interesting choice to need glasses, not wear them, and sit in the back of the room. Sorry, I don't mean to call you out. That's unkind of me. I apologize. See a lot of people getting to the point of busting out the calculator. That's good. Makes me think people are coming close to having some answers. Let's hear them then. What are the solutions? I hear a -8 and a 2. People agree? Anyone want me to do the walk? Cool. So, you'll have noticed during your walk doing that, you end up with some really big numbers underneath that square root, right? I think when you walk it out, that winds up with a 100 under the square root.
Yeah.
Which the upshot is that's obviously a perfect square. If you're going to recognize a perfect square, 10 times 10 is 100 is what you should just know. But whenever you get whole number solutions, it's kind of too late to take advantage of this because you've already accomplished the problem. But whenever you get whole number solutions, you get to know for a fact that you could have done this problem in an easier way. So there's another technique you can use when thinking about quadratic functions called factoring. Doesn't always apply, but when it does, life's kind of nice. Makes the problem easy to solve without working so hard. So, same exact problem. Let's study the same function as you did. Right, you subtract 16 to the other side, you get x squared plus 6x minus 16. I claim that this factors as 2 linear things multiplied together. And how do you go about finding these 2 linear factors? Well, let's start by imagining we gave them a name. Let's call that one A and that one B. If we FOIL out the right-hand side, what would we wind up with? We'd wind up with x squared plus bx. I guess I'm wrapping the positivity or negativity into what b is, plus ax plus ab. So I have an x squared in what I want and an x squared in what I have. That's good. The bit that has an x next to it is b plus a. Over here it's 6. So I need a plus b to be equal to 6. I need a times b to be negative 16. So if I can find two numbers a and b that add together to be 6 and multiply together to be negative 16, then I can factor this thing. And well, there are only so many ways that 16 factors. I guess I just need to check them. So don't worry about the a plus b equals 6 part yet. Give me two numbers that multiply together to be negative 16. 2 and 8. But I need the result to be negative, so how about 2 times negative 8? That works out to be negative 16. 2 plus negative 8 does not add to 6, it adds to negative 6. Alright, so 2 and negative 8 doesn't do. Is there another factorization I could try? Negative 2 times 8. And this is all like scratch walk stuff you would do off to the side. I don't need to see your walk to factor the thing. Negative 2 times 8 is also equal to negative 16. Negative 2 plus 8? 6. Cool. So it looks like I can use negative 2 and 8 as the factorization. So that means x squared plus 6x minus 16 is secretly the same as x minus 2 multiplied by x plus 8. People feel pretty all right? So this is like a sneaky idea, but once you set up the problem that you need to solve, you can find those a and b easily enough if they exist. Only so many ways that 16 factors. All right, so if you want to solve this equation, then you could just as easily solve x minus 2 multiplied by x plus 8 equals 0. And here's the exciting thing. I have two numbers multiplied together to be equal to 0. What's the only way I can multiply two numbers together and have the result be 0? Not x is 0. One of those two numbers has to be 0. If neither of those two linear pieces were 0, then their product would not be 0. So whenever you see two things multiplied together and set equal to 0, you can split the equation. And that's something that's special about just 0. If I had a 5 on the other side, factoring would have been worthless. This would not have helped. So x minus 2 is 0, or x plus 8 is equal to 0. Are both of those equations easy to solve? So what's x? What are the solutions of this equation? 2 and negative 8. Same as we already knew. But notice, no big numbers came up in this process. So it's often computationally cheaper. It's easier to do to factor an equation when you want to solve something set equal to 0. But there's no guarantee that you can factor it. But if you see the numbers, they don't look so bad, looks like there are some useful factorizations to use, try to factor it. If you can't, then you have to use the quadratic formula. Groovy. Folks feel pretty okay? All right. For the remainder of the period, my goal is to talk about a technique called completing the square. So if I say completing the square in the context of a quadratic function, how many people already have an idea what I mean? Awesome. Okay, cool. So let's talk about completing the square. And in order to motivate it, let's actually start with something that's already been completed the square, that you've already done completing the square to. So let's suppose that I asked you to graph this function. In fact, that looks an awful lot like the function that I will ask you to graph tomorrow on that quiz. Does that look like something you know how to graph? Yeah. So you go about that. So you'd start with just x squared, and then what would you need to do to it? by 2, down 3. Cool. So, what's the graph of this thing going to look like? It's going to look like a upward opening parabola, which has been shifted to the right by 2, and down by 3. Thought I fixed this graph so that I had enough space to like do it without adding things to it. All right, so there's the vortex of the parabola. It's going to open upward. And notice I didn't want to take the effort of carefully finding exactly where the y-intercept is, so I didn't bother drawing a y-intercept. I didn't want to carefully find the x-intercept, so I haven't drawn the x-intercepts. Should we take the effort of finding those? People think that's worthwhile to do? People want them done? Cool, let's do them. How do you find the y-intercept? That's the easiest one. Yeah.
You plug in 0 for x.
0 for x. So let's get the y-intercept by plugging in 0 for x. So let's see, 0 minus 2 quantity squared minus 3, 4 minus 3 is 1. Cool. How do you find the x-intercepts? Yeah.
You plug in 0 and 4.
0 for y, and you solve for x. So let's do that. To find the x-intercepts, it looks like I need to solve 0 equals x minus 2 squared minus 3. How many people would look at that and say, I want to like FOIL out the x minus 2 squared so I can use the quadratic formula? That's fine, but your instinct is too mechanical. This is much easier to do without doing that. There's only one x in that formula. Whenever you see a formula with only one x, you should try just moving everything to the other side. You can do that in this case, right? So let's do that instead. Add 3 to the other side. 3 equals x minus 2 squared. What next? Yeah.
Square root.
Square root. And whenever you want to do a square with a square root, you get a plus or minus. Plus or minus 3 equals x minus 2. What next?
Add 2 to both sides.
Add 2 to both sides. 2 plus or minus root 3. And unfortunately, those aren't like whole numbers, so it's going to be hard to graph them nice without, busting out a calculator now. All right, neat. So we just have the graph. We know what it looks like. On the other hand, what if I did ask you to FOIL this out? What would you get? How many people want, like, a refresher on foiling right now? Cool. Let's remember how to work out a binomial squared. So, this is, let's do this off to the side. X minus 2 squared, what does that mean? That means x minus 2 multiplied by x minus 2. And if you now want to work out what that product is, well, you need to multiply x by x to get x squared. That's the F in FOIL for multiply the first terms together. The O in FOIL is for outside. X times negative 2 is minus 2x. Inside, the I in FOIL is for inside. Minus 2 times x. 2 times 2, the last term is 4. So whenever you see a sum of things multiplied together, multiply each term in one sum by each term in the other sum. And now I need to remember that there's that minus 3. So when you FOIL this out, what do you get? You get x squared minus 2x, so minus 4x plus 4 minus 3. Any more simplification to be done there? Yeah, there is. What's 4 minus 3?
1.
Cool. X squared minus 4x plus 1 plus 1. Cool. So, because I was careful in at least one regard, notice that's the same as this function. So let's suppose I now asked you without a calculator to graph that function. What would you tell me its graph looks like? The thing we just graphed. It's the same function. We've just graphed it. So what's the point of this example? If if I had some way of reversing this process, of going from x squared minus 4x plus 1 back to x minus 2 squared minus 3, then I could easily graph this by graphing that. The process of going from this to that is completing the square. So completing the square, it's more like a goal than an algorithm. How you get it done is an algorithm, but completing the square is a goal. It's a task to accomplish. Completing the square is the act of rewriting a quadratic function, ax squared plus bx plus c, as capital A, x plus capital B squared plus c. And here I've used capital letters just to remind you that these coefficients aren't the same as those coefficients. They had to do with each other somehow, but they're not like the same. So, with my remaining 15 minutes, I want to go through an algorithm that completes the square. Once we have that algorithm, there's also a completing the square formula that I'll go ahead and write down, and then you on your own will have to verify. If you want to internalize that algorithm, no, if you want to internalize the formula, then you don't have to use the algorithm. You can know the formula. So let's do it. Oh, so let's list off one path. So this lets you easily graph. From this graph, can you tell me what the minimum value of the function is? What's the minimum value? -3 is the minimum. And you even know what input gives you that minimum. I guess it's x equals 2. So, if you can complete the square, you can graph. You can read off things from the graph, the minimum, maximum. And in fact, the quadratic formula, why is it true? It's true because of completing the square. So, let's do this. So, in order to demonstrate the strategy that you can use to extract like a formal algorithm, let's just apply the idea of completing the square on this. Let's try to complete, that should be y equals. Let's try to apply completing the square on that thing. And here's the plan that we'll use. What we'll try to do is just gather all of the x's in that formula together into a single thing that looks like x plus or minus a number squared. And in order to figure out what that'll look like, before we even start this algorithm, if I take x plus b squared and FOIL it out, what do you get? And I want you to do it. X plus b squared. Since I see people not writing, I'll give you at least a starting point. That's the same thing as x plus b multiplied by x plus b. Now that that's written down, FOIL that out. So multiply every term in x plus b by every term in the second x plus b. Add them together. What do you get? Yeah, what is it?
X squared plus 2xb plus b squared.
X squared plus 2xb plus b squared. People agree? Anyone want me to do it now that you've done it? Nice. So, x squared plus, I'm going to write the x's last, not for any particularly good reason, but just because now I want to think of that 2b as like a coefficient. So if I ever see in the formula that I write down x squared plus 2bx plus b squared for some number b, I can replace that with x plus b quantity squared. So here's the game. I'm going to try to do stuff to this formula until I see one of these staring me in the face. And the first thing I see that makes me unhappy is there's a negative sign next to the x there. There's not a negative sign next to the x here. So in order to not have a negative sign next to that x squared, let's multiply both sides by -1. Does that seem like a fair enough idea? All right, so we do that. Negative y equals, ooh, I'm going to do something wrong and you'll tell me what I did. X squared plus 6x minus 3. Yeah, what did I do wrong?
It should be x squared minus 6 plus 3.
Nice. Right, you need to multiply everything on both sides by -1. Cool. All right, so that's nice. I see this x squared, Tom. That minus 6x, could I rewrite that as 2bx? For some choice of b? Yeah, I think so. 6 is even. In fact, even if it were odd, I could write it down as something times 2, because I know how to divide by 2. So in order to turn this into the 2bx and figure out what the b squared needs to be, I'm going to start by getting rid of that 3 term. I'm just going to move it to the other side and I'll remember it later. So minus y minus 3 equals x squared minus 6x. Now there's no constant term. So I would like to pick my b so that 2bx is the same as minus 6x. So what does it look like I would like b to be? I want this negative 6x to be 2bx. What's a good choice of b? Well, negative 3. So it looks like I would like b to be negative 3. But that means I need to see a plus b squared. So I need to see a plus 9. Do I see a plus 9 at the end of that equation? Could I? What would I need to do to get a plus 9 at the end of that expression? I can add 9 to both sides. So let's add 9 to both sides. So minus y plus, minus y minus 3 plus 9, minus 3 plus 9 is 6, but I'll do that in the next step, is equal to x squared minus 2 times 3, yeah, let's leave that as 6, minus 6x plus 9. All right, so what's the whole point of doing this? This side is now a perfect square. We have now completed the square. So the stuff on the right, I can write that as x minus, you told me b was 3 already, so minus 3 quantity squared. So I can replace the thing on the right-hand side with that perfect square to get minus y plus 6 equals x minus 3 quantity squared. Seem okay so far? All right, could I now do some more algebra to just get y on its own? Let's do that more algebra to get y on its own. I guess I need to add 6 to the other side. Wait, subtract 6 to the other side? Subtract 6 to the other side. And then deal with the negative sign in front of y. So subtract the 6, negative y equals x minus 3 quantity squared minus 6. Deal with the negative sign in front of y. Y equals negative x minus 3 quantity squared minus 6 becomes plus 6. That feel pretty okay? All right. So in order to reinforce why on earth you would do this, this is enough that we can now graph. So let's graph this now. So to graph that function, let's just talk through what you would do. So you'd start with x squared, so upward opening parabola. And what would you do to it?
Oh, right 3 and up 6.
Right 3, up 6, but you skipped a step.
Oh, yeah, it's flipped over.
So you'd start with y equals x squared, you'd flip it upside down, then you'd go right 3, up 6. So you'd see this happy little turning point, this vortex at 3, 6. And then you'll see a parabola. Seem all right? Nice. Yeah. So let's suppose I did ask you to like give me the maximum value of this function. Could you do it now? Sure could. It's 6. The maximum is produced by x equals 3. So with the remaining time, let's see how people feel. Do people feel like they could apply completing the square of the algorithm on their own to this next example? Anyone want to say no? Cool. Then let's talk through it. So remember the philosophy. The philosophy is to get a copy of this to show up on the side with the x's. And it should contain all of the x's. So let's try to apply this completing the square idea on that thing. So the first thing I see here is, let's see if I can arrange this so you can see as much of what we did previously. There. The first thing we did is we arranged that we just saw x squared without a coefficient next to it. So let's do that first. What can you do to make that 2 not be next to that x squared? Yeah. Let's divide everything in sight by 2. And that's, I guess, going to be mildly annoying because I see an odd number, but that's okay. Sometimes things are annoying. It won't be that annoying. Yeah.
Does that include y? Divide y by 2?
Divide y by 2 as well. Divide everything on both sides by 2. So what will we wind up with? I think we'll wind up with divide by 2. So we'll have 1/2 y equals x squared. That 6x will become a 3x minus 5 halves or 2.5. What do people prefer? 5 halves? 2.5. Cool. I think it was a result of like 3 to 2 with a class of almost 40. So if you like 5 halves, don't let me yuck your yum. Stick with the 5 halves. All right. So there's what we see. So I'd like to see an x squared plus 2bx showing up. I see x squared. I see something times x. But now let's just get that constant over to the other side so it doesn't screw us up. So let's move that 2.5 to the other side. Add 2.5 to both sides. So 1/2 y plus 2.5 equals x squared plus 3x. All right, so I need this to be x to be the same thing as 3x. So what seems like a good choice for b? In that, like, could you look at that equation and solve that for me?
3 halves.
3 halves? Cool. I guess I'm using decimals now, so 1.5? If you want to use fractions, use fractions. I'm just going to try to be consistent. So it looks like my target b is 1.5. But I need to see a plus 1.5 squared on the side that has the x's. Do I see that right now? Could I, though? Yeah, let's just add whatever 1.5 squared is to both sides of the equation. So plus 1.5 squared, 1/2 y plus 2.5 plus 1.5 squared is equal to x squared plus 3x plus 1.5 squared. The right-hand side is now a perfect square. This side is now equal to x plus 1.5 quantity squared. Seem okay right now? So I did some stuff to the right-hand side to just try to see a perfect square staring at me. I figured out what b had to be. Then I did some more work to get a plus b squared at the end. Now I guess I just need to get y on its own again? Is that going to be reasonably easy to do? Yeah, add some stuff back to the other side, or subtract as appropriate. See what we wind up with. So let's see, I think I'll see 1/2 y equals x plus 1.5 quantity squared. I had to subtract this 2.5. Should we expand out what 1.5 squared is as like a decimal in more detail? Does that seem like something you would want? All right, well, I get scared whenever I need to square a fraction, and I have a calculator. 2.25. So minus 2.5 minus 2.25. All right, we coming along? I guess now I just need to multiply both sides by 2 and maybe simplify this decimal number. So y is equal to 2 multiplied by x plus 1.5. Oh gosh, I'm out of time. Plus, well then I'll leave this bit to you. And then to actually finish it out, like you should compute that last decimal at the end. But I think that's not the point of today. All right, so if you want to complete the square, what's the game? First is that the coefficient in front of the x squared is 1. Then try to get the constant term to the other side so it just doesn't bother you anymore. Now you know what b has to be. It's 1/2 whatever the thing next to the x term is. Add b squared to both sides. Replace the right-hand side with x plus b squared. Now get y on its own. Groovy. And what will we start with next time? We will start by writing down, instead of this algorithm, a formula. That formula will just tell you what A, B, and C are.
Your office hours are from 10 to 11?
That's right.
Okay. I'd like to stop by a few questions I'll leave at work.
Yeah.
Can't figure out.
Did I tell anyone in this class that I would meet them at 11 o'clock? Okay, good, I can't. I told someone I would meet them at 11 and I can't, and I don't know who. It'll be significantly less than in the same. I think on the far side, like it's 2 halves. I think it's like 3 questions on the no calculator side and then like 3 or 4 on calculators on the outside. Okay. If it helps, oh, don't walk backwards, so I'm fine. Okay. Yeah. That's right.
I applied for the notes for what did you say?
Yes. Have they like gotten you the paperwork at this point?
Yeah, I've seen like a month ago.
Oh, okay. And I've seen the paper. Okay. Yeah, we can do this. So it was through the languages office, or was it?
Was a lot better than
Oh, okay. But the reason was because you speak English as a second language. Okay. I just asked because there are 2 different.
There's Is there a time enough?
Yeah.
Okay, so
Yeah, like it'll be fine. I tell you what, if you need the extra time and like you're just not done, then I'm going to continue to be in this room. This test is just happening again. So you'll hand me like your copies of the test. You'll take 10 minutes because that's like the transition time. Then you'll come back and I'll give you a seat in here again and you'll finish up the exam.
it's just the chapter.
Yeah, it's the stuff we've done. It's the stuff we've done so far, not quadratic functions. And shoot me an email so I can go through my reference too. And, yeah.
Okay, thank you.
Thank you.
Can I email you some questions? I had a question on one of the homeworks about like, we had a graph and then we had to write the formula of the graph. But I couldn't figure out how to decide like how much it condenses.
Oh, okay. It would be easier to do that sort of conversation in Boston, but can you make my office hour or no?
It's at 1?
No, on Thursdays it's at
Yes.
Okay, cool. If you can't, then go ahead and like send me the video question, but it's much easier to ask this kind of question. Okay. Yeah. Ooh, stop the recording.